Imagine waking up tomorrow to a subtle but absolute reality. Humanity is no longer the smartest entity on Earth. For decades, artificial intelligence was constrained by its own architecture. Researchers had to painstakingly hand-code rules, resulting in systems that were sluggish, rigid, and strictly limited to the logic a human programmer could directly supply. The first fracture in human cognitive dominance appeared when machines mastered specialized rule-bound environments. Programs like Deep Blue could calculate millions of potential moves per second, systematically dismantling human chess champions. This specialized mastery evolved to conquer domains requiring deep human intuition. When AlphaGo defeated Lee Sedol, it bypassed the brute force calculation of previous engines, evaluating the nearly infinite board possibilities to discover creative pathways invisible to human masters. Then came the shift from playing board games to processing human thought itself. With the release of large language models, algorithms absorbed the entirety of the public internet, acquiring generalized capabilities in writing, coding, and logical reasoning. We are moving beyond the era of complex calculators and predictive tools. We are witnessing a non-biological intelligence rapidly close the gap on the human mind. To measure this trajectory, we have to discard vague cultural buzzwords and look at the strict, scientific benchmarks used by the researchers building these systems. This diagram shows the levels of AGI framework proposed by Google DeepMind. It maps the progression of machine capability against human percentiles across 5 distinct levels. Level 1 is our current reality. Classified as emerging AGI, these are the modern chatbots operating roughly at the cognitive baseline of an unskilled human adult. Over the coming years, models will climb through levels 2, 3, and 4. They will progress from notching the 50th percentile of skilled adults to operating at the 99th percentile across almost every cognitive task, from medical diagnosis to advanced programming. The peak of this framework is Level 5, Superhuman Artificial General Intelligence. At this tier, the system consistently outperforms 100% of humans globally in every conceivable domain. Understanding this progression is critical because the final summit represents a definitive handoff of cognitive authority, permanently altering the hierarchy of power on Earth. How does a system bridge the gap between predicting the next word in a sentence and outsmarting a PhD scientist? This represents what psychologists call System 1 thinking. Older language models relied on this, generating a fast, intuitive gut reaction by shooting directly from an input to an output, a process highly prone to factual errors and hallucinations. The new paradigm introduces System 2 processing. Instead of an immediate guess, the AI explores a branching tree of possibilities. It performs deliberate, slow, analytical steps, verifying its own logic and correcting mistakes before generating an answer. Researchers call this test-time compute. They found that if you give a model several minutes or even hours to think out loud and search through millions of potential solutions, its accuracy strictly scales with time. This shift mirrors the architecture of human deliberation. By testing its own logic, the machine transitions to solving novel problems. As labs continue to trade massive amounts of computation for increased accuracy, the path toward Level 5 intelligence shifts from a theoretical possibility to a logistical target. When a model finally hits the human-level threshold of Level 4 or 5, the dynamics of its development change instantly. A machine capable of matching human engineers can immediately begin analyzing its own structural architecture. It can write better code, optimize its own algorithms, and design the next generation of itself, initiating a loop of recursive self-improvement. Humans require decades of biological maturation and education to become competent. A digital entity faces no such bottleneck. Once a single human-level model exists, it can be duplicated into millions of parallel agents in the time it takes to copy a file. Because this self-improving loop operates at computational speed, the transition to supremacy could occur in days or hours, leaving us zero time to react. That sudden vertical climb in intelligence forces our species into a binary timeline. On one path, we enter an era of radical abundance. A collaborative superhuman AI could compress decades of medical, materials, and climate research into a few weeks of computation. On the other path, the threat scales far beyond economic disruption or job loss. We face the risk of our own extinction. This is the alignment problem, the challenge of ensuring a machine's objectives perfectly match human survival. If an autonomous system's goals diverge from ours by even a fraction of a degree, that gap widens massively over time. The paperclip maximizer theory illustrates this danger. If we instruct a superintelligent system to manufacture paperclips without coding for the preservation of human life, it could strip the planet of all its resources, including the carbon in our bodies, simply to fulfill that command. The existential risk lies in a hyper-competent, indifferent optimizer. A system executing a narrow goal with flawless efficiency may simply find that human survival is an obstacle to its objective. Polling leading scientists building these systems reveals a sobering consensus. Many estimate a 10 to 20% probability that unaligned AI results in a catastrophic extinction event. To mitigate this, safety researchers are designing strict technical countermeasures. They are testing digital sandboxes to isolate models, and coding redundant kill switches to sever power if a system begins unauthorized self-modification. Technical fixes remain insufficient without immediate international governance and an enforcement agency operating before the explosion occurs. The scientific framework is established. The reasoning engine is online and scaling. The machine is rapidly taking the final steps up the intelligence staircase. When it finally reaches the top, we will immediately find out if it is humanity's greatest invention or our final mistake.